In this video, we'll see how bitwise operators work in C programming language. There are how many? You can count 1, 2, 3, 4 bitwise operators, which we have categorized in previous video. This symbol is for bitwise OR. This is for bitwise AND. This is for bitwise NOT, and this is for bitwise exclusive OR. Now let us see. This is referred to as a truth table. If two inputs are applied to bitwise OR operator, if both the inputs are 0, we can see from here, if both the inputs are 0, output is 0. For all other combinations, output is 1. Or you can say if any of the inputs is 1, then output would be 1. So we may have more than one operators, but since this is a binary operator, so at a time it will evaluate with only 2 operands. So for example, we can see here, if you declare an integer and assign it a value 30,000, this is its bit representation. It means internally it will be stored like this. It will be stored like this only. Suppose next value is 31,237. Its representation is this. And here I'm taking as an example the integers which are within 16 bits so that it is easy to draw. Okay, so like in Turbo C++, the size of int is 2 bytes. So 0 through 15. Okay. Similarly, the result would be of OR operation would be 32,565, whose bit representation, which is this one. Okay. Next comes bitwise AND operation. So here, if any of the inputs is 0, output would be 0. Same example, you can check for bit or bit by bit, you can check. So if here one input is 0, another is 1, output is 0. On the similar lines, you can check up to and including 16 bit, that is bit number 15. Next comes bitwise NOT. So here, if the input is 0, output becomes 1, and if it is 1, output becomes 0. So this is unary operator. It does not require 2 operands, so it is unary operator. So example is, if x is 30,000, it is expected that the output would be this. Flip each bit, 0 becomes 1, 1 becomes 0. Okay. But in the process, if it is Turbo C++ kind of thing, 16-bit system machine, then the result would be different. Here, for sake of explanation, I have written this bit pattern. So we expect this to happen, but here it reaches to the limit. So in programming example, we'll see this will be printed, this should be printed as a negative number. Okay, so this is the property of bitwise NOT operator. And the last one is bitwise exclusive OR. Here you can see, if the two inputs are different, then only output would be 1. If the inputs are dissimilar, the output is 1, otherwise output is 0. You can check here. So again, the same integers, x is integer with a value 30,000. This is 31,237, same bit pattern, and you can check here. These 2 bits are different, so output would be 1, and so on. So accordingly, the output would be 3,893. Leading 0, I have just printed to explain, but most of the time by default the output would be printed as 3,896, that is 93, 3893, it would not print leading zeros, but we can make it print like that. Later in some other video we'll see how to do that. Okay, so now let us see some example. I have already made one program which, so here standard include file, and I have declared two integers. So when you type two integers, it would print in these subsequent lines, subsequent printf functions, the values of these operators, effect of these two operators. So let me execute the program. Bitwise operators, bitwise operators. It is asking two integers. So suppose I supplied 5 and 10. So in response to first printf, this is the result. X equal to 5, y equal to 10, x or y is equal to 15. Similarly, for second printf, it is printing AND, the result of bitwise AND operator. Third printf, it is printing the bitwise operator, result of bitwise exclusive OR. Now here it is interesting. Now you can see here, just close look. Here I have taken the bitwise NOT of the first input supplied, which is 5. 5 when produced as, when bitwise NOT operator is applied, the value would be -6. Now same thing we can do again. If I supply 5 -6, okay, now you can see -6 bitwise operator x -6 is what? Bitwise x applied -6. Okay, so these values applied. So 5 -6, because I have taken the bitwise NOT of the first operand. Now if I just change 5 to, I'm rerunning this program just to explain the bitwise NOT. So if I supply -5 and then 10, suppose, so pay attention to this one. So bitwise NOT of -5 is 4. It means you take the magnitude and reduce it by 1. And here take the magnitude, which is 5 itself, and increase it. So bitwise NOT of 5 is -6 and bitwise -5 is 4. I have written a small program to count number of bits present in a number. So that will make it clear. So bit count. Type an integer. So if I type 5, now you can see, because in my machine, which is 64-bit, size of an int or integer is 4 bits, that is 32 bits. So what is the bit pattern? Bit pattern is this one. So only significant bits are these three, last three. 101, this is 5, they make it 5, and you count number of ones is 2. Okay, now if I rerun this program and supply -5, so with -5, what happens? With -5, this is the value, because what happens is most of the computers, negative numbers are represented and stored using 2's complement method. What is 2's complement? Take 1's complement and add 1. So 1's complement is nothing but flipping the bits. 0 becomes 1, 1 becomes 0, and add 1. That is binary. Okay, so here how it will be represented? This is this is +5, that is 5. Okay, flip each bit, so this bit becomes 0, this bit becomes 1, this bit becomes 0, and rest all bits become 1. and add 1. So this would be the result. So this is the internal representation of minus 5. Okay. Now if this is minus 5, you take its bitwise not. So let me read. So if you take bitwise not of this, what happens? All bits would one bit would become 0 and 0 would become 1 and add 1. So this would be nothing but what? 4. So you can check with different values. So what happens is when you take bitwise not, so most significant bit which normally represents sign. If it is 0, number is positive. If it is 1, number is negative. So when you take the bitwise not, the most significant bit becomes 1, and hence the number is to be represented as a negative number, and that is why the result. So bitwise not of minus 5 becomes plus 4, and bitwise not of 5 becomes minus 6. That is all in this video. Thanks for watching.